We're going to have a look at a series of index laws or index rules as they're sometimes referred to. First one we're going to have a look at, hence I've just called it index law 1, is this. When we're multiplying powers, and this is key here, if the bases are the same, then we add the exponents. Okay. Very formally, the rule is expressed in this format. Anything raised to the power of m times anything raised to the power of n is the same as a to the power of m plus n. So in other words, I'm trying to multiply this power to this power. Okay? So I'm trying to multiply this power to this power. The bases are the same, and what I end up doing is adding the exponents. Okay? So if we had something like 4 cubed times 4 squared. Okay? Now according to the rule that we've just done, I'm multiplying these two powers. The bases are the same, so this should be the same as 4 to the power of, add the exponents, 3 plus 2, 4 to the power of 5. Let's have a check. Let's be a bit skeptical and check that this is indeed true. If we did have to work out 4 cubed times 4 squared, let's see. What does 4 cubed really mean? 4 cubed actually means 4 times 4 times 4. Okay. And 4 squared actually means 4 times 4, isn't it? Okay. So we've actually got the 4 cubed and the 4 squared. Well, this actually means 4 times itself 1, 2, 3, 4, 5 times. So I can write this shorthand by saying 4 to the power of 5. Lo and behold, my answer is actually correct. Without even applying the rule, I can see that this is indeed the correct answer. Okay? Let's have a look at another example. Suppose we want to write 3 cubed times 3 to the power of 4 times 3 to the power of 6 as a power of 3. Okay? Right, 3 cubed times 3 to the 4 times 3 to the 6. I'm trying to multiply all three of these powers. The bases are all the same. So according to index law 1, I can simply add those exponents together. Okay, so it becomes 3 to the power of 3 plus 4 plus 6, which is 3 to the power of 13. As a single power of 3. Okay. Let's have a look at another example. Suppose we wanted to simplify 8 cubed times 8. Okay. Now 8 on its own, and this is a special note to take, okay? 8 is the same as 8 to the power of 1. Anything to the power of 1 is just that number itself, okay, or that term itself. So here, this is the same as 8 cubed times 8 to the power of 1. So I'm trying to multiply the powers where the bases are the same. So that means I keep the base there and I add the powers, 3 plus 1, so it becomes 8 to the power of 4. Okay. Now let's just check that. If I wanted to work out 8 cubed times 8, well, let's see, 8 cubed is the same as 8 times 8 times 8, isn't it? And then times 8 again, well, that actually means 8 times itself 4 times, so this is the same as 8 to the power of 4. I know that that's correct. Now this can be applied to variables as well. If you're asked to work out x to the power of 5 times x to the power of 10, I'm still multiplying two powers and the bases are the same. So according to index rule 1 or index law 1, this will become x to the power of 5 plus 10, okay, which is equal to x to the power of 15. Okay. The only time the index law 1 does not work is if the bases are different. So if you had something like x to the power of 5 times y squared times x to the power of 3, okay, yes, we're trying to multiply all of these powers, but only this base and this base are the same. This one is different, which means that sure, I can multiply the x to the power of 5 and x cubed using the index law 1. So this will become x to the power of 5 plus 3, which is 8, times y squared. So my answer here will literally just remain as x to the power of 8y squared, because I cannot apply index law 1 in this situation because my bases are different.